Okay, so let me begin again. Chi-square test for independence. What you need to do is you need to find whether there's a relation between the gender and the exercise, whether they do or not, whether any relation is there between them or not. So that's what we are looking at. Now, your null hypothesis is always the variables are independent. What if my variables are independent? They don't depend on each other. Yeah, whether the gender and exercise has no dependence on each other. And your alternative hypothesis, H1, is that the variables are dependent. Means, exercise, whether you exercise or do not exercise depends on your gender. So we are going to test this using hypothesis testing. And for that, we have to use chi-square independence, test for independence. It's very simple to see this. When you have a table like this, generally it will be chi-square. Now, sometimes they won't give you this total ka column, sum column. You have to add the males, that will give you sum of all the males. You add the females, you'll get the sum of the females. You add vertically, you'll get a sum of people who do regular exercise. You add vertically, you'll get people who don't do regular exercise. And when you add this, you'll get 400 each way. Now, the total columns are important because they help us to give us what we call expected frequency table. Now, when you're doing expected frequency table, what I can do is I can tell you that to find expected frequency. So see, imagine this is all blank. All this is not given. What you need is you have only the totals. So to find the first expected frequency, what we do is 208 into 216 divided by 400. So you think of the triangle like this. This into this divided by 400. Similarly, here what will it be? This into this divided by 400. Similarly, 208 into 184 divided by 400. Okay, so that's how we get to expected frequency. Then what you have to do is you have to everything all this calculator does. You don't have to do anything of this sort. Correct? You have to use the calculator only. Now I'll teach you how to do it on calculator. Now the degrees of freedom that you need to remember. Degrees of freedom is the concept in number of values that they are free to change. So number of degrees of freedom is, you have to learn this formula. Again your calculator gives you this number of rows minus 1 into the number of columns minus 1. Your p value, your calculator will give you the p value. You compare your p with SL. And you remember the dictum, low p, no H naught. Yeah, so you reject. So low p, you reject your H naught. Correct? So this is what we need to do. Now as I do it, I'll explain you things better. Now, first one. So draw to work when you do, what do you do? 46. You take the column total, you take the row total divided by the total of total. So 46 into 44 upon 80. Then you have to use your calculator to work it out. Tell me cycle to work. What is the expected value? We are finding the expected frequency. And this is called a contingency table. It's a two-way table. So tell me about the cycle. Cycle to work. So tell me what are the numbers? 14 divided by 80. Tell me public transport. Then female 46 into 36 divided by 80. Next. Yes, good. 20 into 36 divided by. Correct. Then you use your calculator to work this out. Okay. You followed how to get the expected frequency. Now for C you have to do the which one you have to do? So generally in IB, they'll give you like some number C. They'll ask you the question again. Let me repeat. The question is asking you construct an expected frequency table for the contingency table. Contingency table is your two-way table. So now here we have the data that we have: sunburnt, not sunburnt, wore hat and sunscreen, wore hat or sunscreen, wore neither. So what you need to do is you go to run matrix, correct? You go to matrix, enter. Now without a total column, you look at the number of, sorry, again, I'm recording it anyway. So you'll forget, then also it will be there. So you go to run screen, then go to F3 matrix. Your matrix A will consist of the observed value. I'm looking at sum number 3. These are the observed value. Don't take the sum column. Look at the number of rows and number of columns. How many rows are there? Rows are, these are 2 rows. 2 rows. So you enter, press 2 rows. And how many columns are there? 3 columns. Don't count the sum ka total rows and columns. Enter this. Now you enter this data which is given. 3, enter. 5, enter. 13. You enter whatever is given in the data. 36, 17 and 1. Okay. Now we exit. Okay. Exit. Now what you do is you go to again math, statistics, test, chi, yeah, and you take two-way, correct? We have put the observed value in matrix A. Automatically we have done that. You expected automatically it will calculate it, give you in B. So I'll enter this. It gives you the chi-square in that. And if you want to see the matrix, you press this. So automatically it gives you this matrix B. You enter it. These are my observed values. So you'll have to watch this video again because there are a lot of steps in calculator. So this will give you the observed matrix. So you have to redraw this table, and instead of putting these values, these are the observed values. You don't have to put these values. You don't have to put these values. Your observed values will be 10.92, correct? 6.16. This is what we'll write in your answer paper. In your answer paper, you'll write the expected values. Observed value was given to you. You follow this. And sum though, obviously, I didn't do the sum. You can just fill up the sum. That is quite easy for you. Then with sum, you have to do. Now listen. Next question. Let's do this. Sum number 3. No, but we'll do more sums. Huh? Okay. This contingency table shows the responses of randomly chosen sample of adults regarding the person's weight and whether they have diabetes. So weight, diabetes or non-diabetic. Conduct a chi-square test for independence at 5% level to determine whether there's a link between weight and suffering from diabetes. So what is your null hypothesis? What did I say? What's your null hypothesis? Null hypothesis is always independent. So what will you say? Correct. There's no, so weight and diabetes, person's weight and diabetes are independent. And what is the alternative hypothesis? Correct. So remember, your H naught will always be independent. H naught, weight and diabetes are independent. Don't forget this. No change. Remember, null hypothesis, no change. And weight and diabetes are dependent. What test are we going to use? They've given you. So you have to write that. The test that you're using, chi-square test for independence. Using chi-square, this is what will you write in your notebook. Chi-square test for independence. What is the significance level? That is also given, but you have to write it again in the paper, 5%. So now what will you do? Tell me. You'll enter this observed value. These are all the observed values in your calculator. So exit, go to menu, go to matrix, enter this value. Now again, this is 3 by 2. So I didn't have to change anything. 11, 19, 26, 79, 68, 69. Okay. Now what do you do? Menu, statistics. Where will you go? Menu, test, chi, two-way. Correct? Observe matrix we have put it already. Yeah. So if you want to see your matrix A, let's check whether it changed or not. Yeah, I changed it. Correct? You can exit. You have to copy this also in your paper. That's your expected value. Expected matrix, you copy this. But more than that, importantly, you have to write this. So what's your chi-square? Chi-square calculated value is how much? 6.61. What's your p-value? 0.368. And what is your df? Degrees of freedom. How do you get degrees of freedom? You remember? Yeah, it calculates for you, but the formula is number of rows minus 1, column minus 1. So 3 minus 1 into 2 minus 1. Your calculator does everything, but I'm just saying that. So this is the degrees of freedom. Now, what is the thing that you'll draw? What is the conclusion you'll draw? You compare your P with SL. What's your SL? 0.05. What's your P? P is 0.0368. This is the SL. So is a P lower than SL or greater than SL? So what do you do? Reject what? Means, what does it mean? Means you accept H1, means weight and diabetes are dependent. They're not independent. So heavy people are most likely to get diabetes. Basically, that's what it means. Okay. Now try the fourth one.